Session IOT204, innovating and building and modernizing connected vehicle platforms with AWS IoT. Now, for those of you in the audience that are building or enhancing or designing a next generation connected vehicle platform for your company, I've got great news for you. You are absolutely in the right place. This is a session that's focused on the ways that we help you innovate around your connected vehicle platforms. And we have a lot of ground to cover. We have reference architecture, stories, great content, a lot of ground, so we're going to jump right into it. So really fast for speaker intros, my name is Larry Snow. I am the principal worldwide go-to-market lead for automotive and connected vehicle for our IoT services. Joining me today will be Andrea Ketzer. She's the Director of Technology Strategy for Connected Mobility for the Automotive Business Unit. And then last but not least, we have a very special guest. Yozo Takehara will be joining us from Honda Motor Company, from American Honda Motor Company, the unit lead for the Digital Services Development Division. And with that, a real fast overview of the agenda. I will be covering connected vehicle platforms with AWS and the 3 areas of innovation we can help you with related to our IoT services. Next, Andre will cover modernizing the vehicle data platform. And then Yozo will be talking about his firsthand experience helping Honda migrate their platform to AWS IoT. And last, there will be some Q&A afterwards, but we'll shut down the session and then we'll wait over here. So if you have any questions, feel free to approach us and let us know. So every good session starts with a story. This story goes all the way back to 1885 and the Benz patent motor wagon. This is widely regarded as the first popular modern automobile. There's a rich story about how this came about, but the part of the story I like best is the inventor's wife, Bertha Benz. She's famous for 2 things. First, she took the world's first road trip in an automobile, traveling 60 miles to visit her mother, which says a lot about her courageous spirit and personality. And second, while she was on this trip, she discovered that there was a problem with the brakes. So she stopped in and worked with a local cobbler and invented the world's first replacement leather brake pads, an iteration of which we are still using today, see today. So why do I tell the story? First, to highlight an amazing woman and pioneer in the automotive industry, and that this is the beginning of a lineage of individuals and women like Andrea Ketzer that are still doing awesome things in the automotive industry. And second, because adding innovations to vehicles is nothing new. This has been happening since 1885 and it continues today. And it is the cloud that enables all kinds of interesting new use cases that we'll be going over today. So what is it exactly that the cloud enables? At AWS, we're helping OEMs around the world build a spectrum of new features and capabilities that leverage cloud hyperscale technology and infrastructure. Things like ADAS and autonomous vehicles, EV optimizations, battery health monitoring, map and trip services. You have connected grid and infrastructure, over-the-air updates, subscription management, AI/ML integrations. All of these things and many more are getting built and delivered better, faster, more securely, and easier, leveraging the AWS cloud. And why is it that companies are choosing AWS to build their connected vehicle platforms? There are a number of reasons, but these are the top reasons that OEMs and others cite. Number 1, scalability. The ability to deploy 1 million or 25 million vehicles on infrastructure that is literally ready to go today. This is one of the top reasons that we see companies migrate from third-party solutions over to IoT because of issues they're having around scalability and resiliency. Second is multi-region, the ability to deploy those 25 million vehicles in any region around the world that's important to you, including China. And last but not least, cost savings. We've worked with customers that have migrated their message broker to IoT Core for MQTT that are saving more than $1 million annually. So, for all of those reasons and many more, we now have more than 270 million devices that are connecting into the cloud with IoT Core. And many of those are vehicles from OEMs, tier ones, telematics solution providers, and others in the industry that rely on the IoT services for their connected vehicle platforms. Now, as context for the next set of slides, I want to go over how AWS views a connected vehicle architecture. So at the bottom, we have a devices and hardware layer, ECUs, TCUs, gateways, and vehicle networks that need to communicate with the cloud backend. They would do this through the communication layer, which is predominantly MQTT. On top of that, you have a vehicle data platform, you have your software at the edge, and then you have an operations layer that allows you to manage that fleet of vehicles. And most importantly, on top of all of that, you have the applications and use cases that ultimately are the reason that you build and deploy a connected vehicle platform. So to deliver the architecture that I just highlighted in the previous slide, you reductively have two options. Option number one, you can build your own platform, or option two, you can buy something or integrate a module that's complete. Now, for the builders out there, as you know, at AWS, we love working with builders. We provide a rich set of tools to help you, from infrastructure IoT services that provide those foundational building blocks, to connected vehicle reference architectures and blueprints, to a vibrant partner community with partners like Bosch and Electrobit, and connected mobility solutions that are available in our solutions library. Now, for the other option, if you're in the buy category, you can work with great partners and solution providers that we work with that have built and delivered their solutions with the AWS IoT services underneath. That's partners like Wireless Car for OEMs, Motive for fleet operators, Vistion for OTA, and Continental for AV8S solutions. Whichever path you choose, we definitely still love you, and we are happy to help you integrate your connected vehicle platform with your AWS environment. Now, for those builders out there, this is definitely the focus of the session. The majority of OEMs that we work with already have a connected vehicle platform in place. They're already managing millions of vehicles. And so they come to us with a very important question. They say, AWS, what can you do to help me enhance or modernize or add innovations to my existing vehicle platform? And we actually have a very simple answer. We have 3 services that are available today to help you modernize and do awesome things with your connected vehicle platform. Those are, number 1, IoT Core for managed MQTT, FleetWise for vehicle data collection and management, and Kinesis video streams for vehicle camera use cases. And that's what I'm going to focus on today. So think back to the architecture slide that I shared previously. This is what it would look like to integrate the AWS IoT services into your vehicle architecture. You have IoT Core here that would help with vehicle communication. FleetWise would improve your vehicle data platform. And Kinesis would provide vehicle live streaming capabilities. And with these infrastructure enhancements in place, you can easily build and deploy a multitude of use cases, like remote vehicle commands, or silent test mode for AV8S, or vehicle 3D view, and many others that are available. And we'll go over some of these now. First, we're going to start with the first infrastructure enhancement, IoT Core for managed MQTT. So virtually every OEM and others we work with today have adopted MQTT or migrated MQTT or building with MQTT or doing something with MQTT in some fashion. And that's because MQTT is the de facto standard for vehicle-to-cloud communication. The reason for this, it's low bandwidth, low latency, and has a publish-subscribe model. So by migrating the message broker inside your platform to IoT Core for managed MQTT, not only do you get the most reliable, secure, cost-effective, scalable service, but you also make it easier to deliver new experiences to your end customers. So this is a great example use case of one of those design patterns that we see many OEMs and others build. Using IoT Core, it is relatively simple, straightforward, to enable remote vehicle commands. And this is used to enable start-stop, vehicle start-stop, or door lock, unlock, cabin preconditioning, for heat and AC and many other things. Now, to implement this design feature, you have a companion application that runs on a smartphone or a mobile application that sends a command request into a Kafka queue via API gateway. From there, you have a Lambda that reads from the queue and then updates the commands database or the commands table in DynamoDB. You then, if the vehicle status shows connected, which is also tracked in DynamoDB, a command is sent via IoT Core and a request response topic to the vehicle. The vehicle then implements the command, sends a response back via MQTT, and that finalizes the command. Now, I know that was a very quick overview of this design pattern. Just know that later in the session, Yozo will describe exactly how Honda migrated to IoT Core and implemented this very functionality in their connected platform. So next, infrastructure enhancement number 2. Following the migration to IoT Core from managed MQTT, the next logical step is for you to examine ways that you can improve your vehicle data platform. That vehicle data platform is composed of 2 parts. You have the vehicle data collection that's happening in the vehicle, and then you have a cloud backend for data routing and data management. This is precisely why we engineered and launched AWS IoT Fleetwise, which is a fully managed service that we developed specifically for the automotive industry, unlike anything out in the field today, that makes it easier for OEMs and others to model, collect, and manage, their vehicle data, all from within your cloud environment. So, we don't have a lot of time to go over all of the awesome capabilities of Fleetwise in the session today, but know that we continue to innovate and add new capabilities based on customer feedback. And we launched some awesome new Fleetwise capabilities during reInvent this week, and Andre will talk about these features in the next section. So let's look at another design pattern that leverages Fleetwise to build a vehicle health monitoring application. So in this scenario, the OEM has integrated Fleetwise into their vehicle stack, which you see on the left-hand side. That would be based on the open source reference implementation of the Fleetwise Edge agent. Using the data campaign construct, the Fleetwise agent would ingest data from the CAN bus or vehicle networks or video systems and transfer that data into S3 or time stream based on the events, rules, and conditions that you define within your cloud environment. For the external applications on the mobile client, a request is made from mobile application to see the health of a vehicle or the status of a vehicle. That request goes to the cloud via API gateway. The data is then captured from the appropriate data store and sent back to the mobile application for visualization. For internal applications, most customers are using Managed Grafana or QuickSight to build dashboards and for analytics and insights and other applications for internal use. And this is just one example of many, and there are even many more advanced use cases that can be easily built and deployed by integrating Fleetwise into your connected architecture. Now, the third way to improve your connected platform is to integrate Kinesis Video into your platform for vehicle camera use cases. So what is Kinesis Video Streams? Kinesis Video is a fully managed service that provides real-time streaming of video and audio into the cloud for storage, playback, and analytics, which can then be used to build out a range of new, interesting, innovative applications with that capability. So with the increasing prevalence of vehicle cameras, both factory installed and aftermarket, it makes sense that OEMs and others are rushing to build new solutions leveraging these rich sensor devices. And what we see from OEMs and others that are building these solutions, things like driver safety monitoring, remote teleassist, remote teleoperations, 3D view, and of course live streaming, which we will go over in the last design pattern that I will cover. So with the integration of the Kinesis client into your vehicle architecture, you can easily build and deploy what we call vehicle security mode. It's a feature that would be available, and this is how it works. You have a car that's parked. That car is using sensors, accelerometers, and other things to monitor activity around the vehicle. When an event occurs, IoT Core sends an alert to a user's smartphone application. The vehicle owner sees an alert and opens up the vehicle companion application and clicks to see a live vehicle camera stream that's in the vehicle. If the vehicle owner sees something and wants to take a certain action, they can initiate a command from their smartphone. IoT Core would send that command back down to the vehicle. It might be something simple like honk the horn, or turn on the lights, or do anything. Those are just simple examples. But that's how the vehicle security mode feature would work. Now, for the architecture, you have IoT Core inside the vehicle that enables push notifications to the mobile applications, mobile clients. You then have, and IoT Core also sends the commands back from the mobile clients into the vehicle. For mobile client communication, you have CloudFront, Cognito, and API Gateway. And most importantly, you have Kinesis video streams with WebRTC for low latency, live camera caption, and peer-to-peer communication. So this is just one example of the many things that you can build with integration of Kinesis into your connected architecture. So for those of you that are interested in more of a zoomed out perspective, this is one example of many that we have for a complete connected vehicle reference architecture, or blueprint. And we have many of these that we share and work with customers as they're building out their connected architectures or modernizing their connected architectures. Now, unfortunately, we don't have time to step through all of this today, but know that there are a number of sessions that dive into this later today, or later this week, actually, and we will share those session IDs with you at the end of our presentation. And not only that, if you would like to work with AWS on your vehicle architectures or as you design the next generation architecture, please work with your account teams to schedule meetings to include our connected vehicle domain experts. And finally, we have worked with many OEMs, tier ones, telematics providers, and others that have done just that, worked with us to build out their connected architectures or to modernize their connected architectures. And these are just a few. Companies like Toyota, Hyundai, Continental, LG, Visteon, and notably Honda, who you'll be hearing about later today, or you'll be hearing from later today. And with that, Andrea will talk about modernizing the vehicle data platform.
Thank you very much, Laurie. Hi, everyone. I hope you can hear me. My microphone is okay. So let's continue. Let's get started with the puzzle. We see here nothing more than hundreds of pieces floating around, unstructured and unintegrated. But if you look exactly of what that is, and if these pieces are integrated in a proper way, if they're assembled together in a proper way, the result is a wonderful car. But what we all cannot see on this picture is the most difficult piece of the car, the software. And the thing about the software is that it generates day by day more and more data. And this is what I'm here to talk to you about today. My name is Andrea. I'm in charge of the tech strategy for auto and manufacturing at Amazon Web Services. Before I joined AWS, I was in the auto industry in charge of product developments like surround view systems or top view, bird view, whichever term you are using. I was developing central electronic control units for autonomous mobility, for ADAS, complex radar and camera systems. At that time, all these products, they are very different, of course, but they have something in common, and this is complexity. Most of my time in the auto industry, we didn't have the cloud. So we had all our data was on-premise. We spent a lot of time to develop services, to manage our infrastructure, to free up memory just to have space for the new data. So I spent a lot of time with my team to find new ways, new tools, new methods to help them to focus on the product development itself and have less undifferentiated heavy lifting. In the next 20 hours, I will be talking to you about how cloud can help develop, can help you accelerate development. Okay, don't be worried. It's not 20 hours. Laurie gave me 20 minutes. So let's get started. Data is, as I said before, is one of the key elements of the car. If the data is delayed, the development is delayed. And if the development is delayed, the next thing which happens is what none of us wants to hear. The product launch is delayed, the start of production is delayed, and that's something which we all want to avoid. Today at AWS, our goal is to help you accelerate the development. Over the last few years, through our deep collaboration with industry leaders around the world, we learned about the vision and the goals and the challenges the auto industry is facing on their journey towards software-defined vehicles. We have heard from automotive customers time and time again that when it comes to SDV, to software-defined vehicles, the most important goals are, number one, is to accelerate software and hardware development, to accelerate innovation and time to market while continuously decreasing the costs. Number two is the absolute desire and expectation to increase the code quality, the software quality, by increasing the test depth. Number three is need to deliver more personalized user experiences. And number four, last but not least, is also the desire to continuously upgrade the vehicle through the lifetime of the vehicle. One of the tools we have just released to help you accelerate your development cycles is the connected mobility solutions. The design of CMS, or Connected Mobility Solution, is our answer to the focus on developer experience at customers like Toyota, Stellantis, and Honda. CMS is transformational in the way how developers will innovate and deliver valuable experiences leveraging in-house development and third-party offerings. CMS includes dashboards, which help you visualize incurred expenses on services or on project or on both, so that you have the possibility to continuously monitor, adjust, and optimize your architecture to save costs. By providing governance and control of deployment, development teams can now innovate and test their new applications without impact to the consumer experience. At AWS, we offer managed services and also solutions, AWS solutions and partner solutions for connected mobility that will help you reduce the costs of development and maintenance of your connected mobility platforms. They will also help you optimizing the data ingest so that you reduce your ingest costs. And we help you develop the data strategy, which helps you deliver more personalized experiences to your end customers. We also offer fully managed services that help accelerate the development. In 2022, if you have been here at reInvent, you were maybe in the session where we launched a new fully managed service, AWS IoT Fleetwise. So that was last year, 1 year ago. This service helps you help automotive companies collect vehicle data and transfer it to the cloud in a very efficient way. It allows you to model your vehicle data and standardize it so that it is easier for the next downstream analytics and applications. Fleetwise allows you to collect only the data which you really need for the use case which you are working on. For example, if you are working on an emergency brake assist feature, for example, then Fleetwise will automatically transfer data which is related to events relevant for that particular feature, like in this case, brake events. So The data is immediately available in the cloud. The developers can immediately access it. They don't need to wait until the test driver, the test engineer, comes out from the car, delivers the physical hard drive, and uploads the data. You save hundreds and hundreds of hours of waiting for your data. And of course, also you save time by looking at data which is not relevant for your use case. In the world of data collection, we see increasing challenges with a massive volume of data coming from cameras. Data that we need to power autonomous mobility and ADAS machine learning. A modern vehicle, I'm sure you know that better, has up to 10 cameras. It has 4 surround view cameras, it has a front-looking camera, it has a rear view camera, it has a driver monitoring, and many more. The number will just increase in the next years. While automotive companies have been collecting vehicle data from vehicle sensors like speed or fuel temperature or fuel pressure, it is becoming more and more important in the software-defined era to collect also other data from other sensors in the car, such as camera, radar, and LiDAR. Vision systems generate a massive amount of data in structured and unstructured formats. The data often lacks context, and it is difficult to synchronize, making it challenging to assemble a full picture which you need to develop your use case. For example, if you want to analyze the accuracy of road conditions detected by the vehicle camera, a data scientist would want to analyze camera data and some other vehicle data, like, for example, the speed and the brake pressure in that moment. Keeping all of those data, which are relevant for that particular use case, synchronized and associated with the same event, it's challenging. It's a heavy lifting, which is typically requires additional software to be developed, and it requires a lot of compute power and time to keep the data synchronized. And now, I'm super excited. I have the pleasure to introduce you a brand new feature of the AWS IoT Fleetwise service, which is our vision system data. So from now on, you can easily collect and organize data from vehicle vision systems that include cameras, radars, and LiDARs. It keeps vision system data, metadata, and also other vehicle sensor data, telemetry data, synchronized in the cloud, making it easier for customers, for developers, data scientists, test engineers to assemble a full picture view of events and gain insights. Customers can get started on AWS by defining and modeling a vehicle vision sensors alongside its attributes and standard sensors. The customer's edge agent, so there is the service has a tiny agent which is running in the vehicle, and it is trained to collect only the data which you, as a customer, as a developer, you specify. And in the cloud, you will see the full picture view of all the data which you need, your telemetry data, your vision data, the metadata related to this, all in one place, and it stays automatically synchronized, making it easier to use downstream for analytics and applications. Continental was one of the first customers who raised our attention towards this challenge in the auto industry. Silent testing or shadow testing, I'm sure this is a term you are familiar with in the auto industry. So Conti came to us and asked for help, asked for a co-innovation to develop these services. So we want to say thank you for the excellent collaboration we had in the past couple of months and years. And we wish you, Continental, and also many, many other customers, success with Fleetwise. Enjoy working with this service and contact us if you need more help. We are happy to jump in and support. And now, my 20 hours are over, so I'm happy to hand over to Yozo-san to talk about the customer journey. Thank you.
Hello, good afternoon. I'm Yozo Takehara. I'm the lead mobile app and the backend server for the digital services and development division on the American Honda Motor. I love this picture. So the Honda Motor is founded in 1959, and it's a first overseas subsidiary of the Honda Motor Company. And we are responsible for the distribution, marketing, and the sales for the Honda branded automobile, motorcycle, power equipment, and marine engine, and jet. As you may also know, we are participate in many motorsports, including Formula One. Additionally, our division, Digital Services and Development Division, have a responsibility for developing, operating the Honda Link services for connected car owners. Today, now I would like to talk about the actual state of the MQTT used in the market car. And first, I will talk about the legacy architecture before we use the MQTT and a few issues. Then, so I will introduce the actual usage of the MQTT, and we'll also talk about some obstacles we faced and how we resolved the situation. Finally, I want to show the actual services using the MQTT in the market. This is a traditional connected car architecture. So let me give you a brief introduction. So it's starting from the right edge mobile app. Once customer want to do the remote operation, the mobile app requests the server to do the remote operation, remote command, and the server side will process the command quickly and ask the network carrier, which car connected, to wake up the vehicle. At that time, the SMS, like a text message, will used to wake up the vehicle. Then, after wake up the vehicle, so vehicle will ask server to retrieve the actual remote command and execute. So finally, after execute the command, the result will send back to the server side, and the server will notify to mobile app the result. Then finally, customer will get the remote command result. But it's so long and complicated, the architecture. But the main point is, so even if we are in the internet world, so we are still relying on the SMS technology. That's a legacy. I want to show the two major issues with this approach. So first is the scalability. So we are increasing the car, and also at the same time, mobile app also increasing. And backend server can scalable. However, the SMS is out of our scalability control. So even if our partner carrier improving the service, but throttled by design. So during the spike, we will be a delay in the operation. The second is a user experience. So it often happens the device cannot get the remote control. And this is the major characteristic for this kind of large IoT device and its move. So that's a server or mobile has no way to knowing this situation before. So that's so in the remote operation, mobile have no choice but just wait the response. Then, so finally, timeout occur. The customer will get the timeout message after 30 to 60 seconds. So this is a bad user experience, we think. Meanwhile, AWS announced the managed MQTT as a AWS IoT in 2015. It's a little bit my story, but I was developing a mobile app in the Honda Motor in Japan. I thought maybe this solution will work. So I came up with this idea, and I created a quick POC. One is the app that simulates the car, and another is a remote app. And I was able to quickly set up the server using the AWS IoT console, and it works fine. At that time, it ended in the in-house demonstration. But after that, I was selected to develop the new and next generation car. So I was able to use this experience to introduce the AWS IoT to our car. I hope that all of you are interested in the new technology and will take advantage of the opportunity like this with a big picture perspective. But so new technology often comes with the risks. So we took approach to minimize the risks and maximize the use of the legacy assets. So actually, the SMS part is where we MQTT actually used. So this approach is very simple change, but works well. So we are able to get big benefit with simple change. Such as being able to wake up the car with low latency and scalable during the spike without throttling. And the ability of the fully managed connected to MQTT server, and knowing that in advance when the car cannot accept the remote control. Additionally, AWS has a wealth of logging and monitoring tools such as the CloudWatch, which was very helpful during the development. Now, I want to show one of the obstacles we faced and how we resolved the situation. It was occurred when separating the non-production to the production environment. We initially tried to manage the non-prod and prod in different AWS accounts. This kind of independent environment like this would be easier to manage, we think. However, later we found out that since due to the AWS IoT restriction, so same certificate cannot be used in the two accounts. So that means it will be necessary to replace the hardware depend on the server environment. So we thought this is major blocker for the development speed. Therefore, the solution we took was to manage AWS IoT non-prod and prod in the same account, but separate the environment by topic. This allows to switch environment without the hardware replacement, so it works fine. Lastly, so I want to introduce the Honda's car that utilize the AWS IoT. This is a new accord compatible with Honda Link services, Honda Link remote services, and released at the beginning of this year. This Accord supports MQTT connection using the AWS IoT mentioned earlier. And the major benefit is faster remote operation. We are able to see 30 to 50% faster than the previous Accord model. So it's a significant improvement, we think. Additionally, starting from this year's Accord, Honda Link remote services is available for all trim. A generation ago, only the highest trim was supported. So that's that every Accord user can get the benefits, such as locking the car even when you are leaving the parking lot, or getting the comfortable climate before you drive, or retrieving the luggage by the mobile app temporarily, even if you don't have the key in the garage, or the geofence speed alert as a parental control for your kids, and security alarm can be detected by that. So if you have this year's Accord, you may want to consider joining Honda Link. In conclusion, the benefit of the managed MQTT using AWS IoT is fully managed service and a long live connection, and be scalable, and it's already in the operation in the production vehicle, like us. And easy to get started using the AWS console. And legacy HTTP asset can be utilized. So this is a little bit old story. So we are already in the next stage. So I hope we can introduce and disclose that kind of new technology in the same stage again. But my closing word is keep open mind for the new technology. Thank you for joining with me today. Thank you. Ben?
Thank you, Susan. So let's wrap up. A few key takeaways for you before you leave the room. So number one, use AWS IoT services to enrich, modernize, and add innovations to your connected vehicle platform. Number two, include AWS in your journey. We love to collaborate and help builders build. And number three, contact your AWS account teams or us and schedule follow-up meetings. We are super happy to engage with you. And as Laurie mentioned, there are a couple of related IoT sessions here at re:Invent during this week. You can see them here. You can take a picture, memorize the numbers, join them. I'm sure you will enjoy them if you are an IoT fan. That's all from us. And as Laurie said, we will be here for the next couple of minutes. Join us. Last but not least, we are a data company. I keep forgetting. Survey is super important for us. Please take a minute or two to use your mobile app, provide a service. We would like to get your feedback so that we can deliver next year at re:Invent a next session, a better one, fulfilling your needs, your expectations. Thank you very much. And follow us on LinkedIn.
Thank you very much.
Thank you.